So let's talk baseball. My favorite thing about baseball is how different players come together to achieve a common goal. Our bodies have something very similar to this. We have a system of different proteins that come together in order to keep time in our cells. This is known as a biological clock. Gaining a deeper understanding of this biological clock can help us all to sleep better at night, in addition to solving problems like jet lag, sleep apnea, and even Alzheimer's. But more generally speaking, keeping time has been absolutely fundamental for nearly all life as we know it. Just to reiterate, our biological clocks are composed of a team of different proteins, just like a baseball team, with the only difference being instead of playing baseball, they're actually keeping time in our cells. And they're about 10 billion times smaller than baseball players. But with that in mind, this scoreboard is a perfect representation of how scientists today can actually view and observe these biological clock systems. They can see big picture ideas, like the final score, what innings runs were scored in, or maybe some additional information, like hits and errors, that you can think of maybe protein structural changes or protein-protein binding partners. But the problem with this approach and all the current methodology being used is that it lacks details. And that's where my PhD project comes in. No longer are we tuning into ESPN to get the latest recap of a sporting event like the current methodology provides, but instead, with my work, for the very first time, we're buying tickets to the game and watching it in real time from inside the stadium. What do I mean by that? At the top, I'm showing one player as if he's had a camera fixed on him throughout the entire duration of the game, watching him fielding, running the bases, and even scoring a run. In my biological clock system, the players are the proteins, and the camera is analogous to a fluorescent dye that I'm physically attaching to one of these proteins in order to monitor it in real time. And that's exactly what I'm showing here on the bottom. This is data that I've collected in lab of a fluorescently labeled protein and its rhythmic activity over the course of nearly 2 weeks. But not only can I look at one of these proteins, I can add a different fluorescent dye to all the different biological clock players and monitor them simultaneously at a never-before-seen resolution. That would be just like adding additional cameras all around the stadium that are each locked on to different baseball players such that we could add them all together and watch the whole game in real time as it progresses. This is the current model of the biological clock and all of its protein players. I like to think of this as the face of the clock, and my new methodology using these fluorescent dyes is the key that's allowing us to open it up and watch all the gears turning on the inside. My work is pushing to unlock the mysteries of how these biological clocks keep time, which is really cool and exceptionally important because after all, timing is everything. Thank you.